So the reason that I've been going on about odds is they actually come up in logistic regression. So remember that when we're predicting the probability, right, with type equals response for logistic regression, what we're doing is we're computing this kind of probability, right? So we're saying we're computing a0 plus a1x1 plus and so on, right? And then we're saying logistic of, which works out to this. So we can do a little bit of math. So 1 over p is 1 over this, and then subtract 1, take the log. So the log of 1 over p minus 1 is this. So 1 over p minus 1 works out actually to 1 over p divided by 1 minus p. So because of how logarithms work, so log of a to the minus 1 is just minus log of a, and a to the minus 1 is 1 over a. So this is minus this. So we flip the sign, and we get that the log of p over 1 minus p is a0 plus a1x1 and so on. So if this is how we predict the probability, then what we're predicting by just computing a0 plus a1x1 and so on, so what you're computing when you're not doing type equals response inside the predict for logistic regression is the log of the odds of the event happening. Okay, so if this is the log of the odds, then this is the probability, and vice versa. So that gets you to being able to interpret the coefficients of the logistic regression. So let's say that you run the logistic regression, and this is what you get. So here we're predicting survived based on sex and age. So now we know that when we're computing intercept minus this, if the sex is male, not doing anything otherwise, minus this much times age, what we're doing is we're computing the log odds of survived equals 1. Okay, so now we can we call it interpreting the coefficients. So we can say an increase of 1 year in age. So if you increase age by 1 year, then the log odds becomes smaller by this much. So we're saying an increase of 1 year in age is associated with a decrease of this much in the log odds of survival. So of course, all other things being equal, so if the sex is what it was. Okay, so that corresponds to a different change in the probability. So if the log odds of an event go down, then the probability of the event also goes down, but not by the same amount. Okay, so another thing we can say, so here if the passenger is male, we subtract 2.5. So that means that all other things being equal, man will have predicted log odds of survival that are 2.5 lower. So by the way, so I have two ways of talking about those things. So one is I just say an increase of 1 year age is associated. So I say associated to avoid kind of causal language. And here I'm talking causally, but I'm talking in terms of the predicted log odds of survival, which is not the same as like the log odds of survival. Okay. So again, all other things being equal, the odds of survival for a woman are this many times higher. Okay, so that is because if you add 2.5 to the log odds, that's the same as multiplying the odds by e to the power of 2.5. And the x of 2.5 turns out to be about 12. Now, the log odds being 12 times higher is not the same as the probability being 12 times higher. That is different.